Hey, you there. Can you solve this question in less than a minute? If you're taking the GMAT and you can't, well then this video is for you. So there's usually two kinds of reactions you can get to that. Right? So one is, what on earth is that? Right? Just looking at some of the symbols involved. And the other one is, yeah, okay, I can understand what's involved here, but can I do it in a minute? No, probably not. So for the GMAT, you first of all need to understand all these different symbols and what they mean. But you also need to be able to manipulate them very quickly because it's a time-pressured exam, and this may not look like it, but it's actually a very easy question to solve in a minute. You just need to know how to break it down and what little tricks to use under time pressure. So what does this video cover? It covers all these different roots, so either square roots, cubic roots, or other like more complex roots, but also how to combine them with exponents, which is another separate video, and also like how to be very cautious with signs, because typically that's another big mistake that people make. Right, so let's talk about roots. Now, first of all, what is a root? Well, you can kind of think of it as the opposite of an exponent or a power in math. Now, what is an exponent or a power? Well, for that, I'd encourage you, if you haven't already done so, to look at our videos and classes on exponents. Now, assuming you have, let's dig in with a simple example. Let's say that we're looking for the square root of 25. The square root symbol is this little squiggle like this, and I'll come back to that in a second. Well, what we're going to do is we're going to look for a number such that when you square it, you get back to 25. Now, you can check the math if you want, but when you do 5 times 5, so you square 5, you get 25. And therefore, the square root of 25 is 5. Now, notice that in the word square root, you have the word square. And that square is the corresponding squaring operation that we have to do to get back to the original number. But there is no 2 in this little symbol here. However, you can actually write a square root with a little 2 on top of it. So just like here, you can write square root of a like this without the 2, or you can write it with the 2. Now, why do we drop the 2 here sometimes? It's just because, well, I guess we're lazy and it's the default way of writing a root. However, you can get another type of root, or many other types of roots. One of them is the cubic root. And so in this case, what we're doing is we're going to look for a number such that when you cube it, you get the original number. In this case, we're looking for the cubic root of 8. And so we're looking for the number such that when you cube it, you get back to 8. And if we take 2, well, 2 times 2 is 4, and then times 2 again is 8. So 2 is actually the number that we're looking for. And notice that in this case, we have a little 3 above the root symbol. Because in this case, a cubic root, well, in order to know what we're talking about, that it's this particular type of root, we need that 3 to not be confused. And this principle works for all numbers, in fact. So we could go one more and have a 4 on it, and don't ask me what that's called because I don't know, and you don't need to know it for the GMAT. But what we're looking for here is a number such that when you elevate it to the power 4, you get 16. And that number again is 2, because 2 times 2 is 4, 4 times 2 is 8, and then 8 times 2 is 16. Now, you're probably wondering, well, this can be become quite complex in terms of math. Well, yes, but in the GMAT, actually, all such calculations will be quite simple, or at least you can break them down into simple steps. So the kind of roots that we've been doing in this simple example are actually the level that you should expect to be doing in the GMAT. You just need to make sure that you break them down into such steps. Now let's look at how we can multiply or divide these roots together. So let's start with an example. Let's say that we're multiplying square root of 3 by square root of 5. Now, what we can actually do is we can combine the 3 and the 5 together under the same root. So we can write that as square root of 3 times 5. And that 3 times 5, we can then do that multiplication and get 15. So square root of 3 times square root of 5 is the same as square root of 15. And we can actually do that on any number or numbers that are positive, right? So keep in mind that a square root only works for a number that's positive, or at least in the realms of the GMAT. And so therefore, when you do square root of a times square root of b, you'll get square root of a times b, or square root of ab. Now, this also works for divisions. So if we have square root of 12 divided by square root of 3, well, this is actually quite handy because we can write that as square root of 12 divided by 3. And why is that handy? Well, we can then simplify the 12 divided by 3 into 4, and that becomes a much simpler expression. Now, this also works for the fancy roots that you can get with higher orders, right? So you could do the same thing with cubic roots, or you could do the same things with roots to the index 4 or 5. Now let's think about how we add or subtract roots. Well, it's not like when we multiply or divide them. There is no simple root for combining them. So unfortunately, we're not allowed to do square root of a plus square root of b and equate that to square root of a plus b. That is not allowed. And it is a common mistake that people make in the GMAT. So for example, square root of 2 plus square root of 3, we are not allowed to say that is square root of 5. So what do we do in that case when we've got several roots that we're adding and subtracting together? Well, what we can do is we can try and factor some terms out. So square root of 50 minus square root of 8, for example. Well, we can't just say that's square root of 42. That's not allowed. However, the square root of 50, we can split that. So if we refer back to the multiplication rules, we are allowed to say that it's square root of 25 times square root of 2. And then separate that square root of 25, which becomes 5. So we can write it as 5 to the power 5 square root of 2. And 8, we can also split that into 4 times 2. And therefore the square root of 8, well, the 4, when we take that out and we square root it, it becomes 2. And so we're left with 2 square root of 2. And at this point, we can combine them, because we both have, in each of the term, we have a square root of 2. And so we can factor that out and say it's, well, 5 minus 2 square roots of 2's. Sometimes it's useful to write roots as exponents using fractions. And I'll show you how right now. So let's say that we have square root of a. We can write that as a to the power of a half. Now, what about cubic root of a? Well, we can write that as a to the power of a third. So remember that square root of a is like having a little 2 here. The 2, we tend to not write it because we're lazy, but we could also have written it there, and therefore that 2 corresponds to the 2 that we have in the half, in the same way that the 3 here corresponds to the 3 we have in the third. And we can use that for any type of root, right? So if this was a 5, we would have 1/5, etc. Now, why would we want to do that? Well, it's when we start combining roots and exponents, it's helpful for putting everything in the same format. So here, if we've got square root of a and we're raising that to the power n, well, we can write the square root of a as 1/2, and then when we take the exponent of that exponent, we multiply those exponents together to get n over 2. So let's see a couple of examples. So square root of 9, we can write that as 9 to the power of half. And that is going to be 3. Now, cubic root of 8, we can write that as 8 to the power of a cube. And we saw already that a cubic root of 8 is 2. Now, let's say that we've got square root of x and we want to raise that to the power 4. Well, we can write the square root of x inside the parenthesis as x to the power of a half. And then we've got a situation where we've got an exponent of an exponent, and therefore we combine those two together by multiplying them. And so we do 4 times a half to get 4 over 2, which simplifies to 2. So this square root of x to the power 4 can actually be written quite simply x squared. So this is typically when we want to go from roots to exponents using fractions. It's when we combine them with other exponents and we want to simplify the calculation. Now let's see what happens when we want to calculate the roots of other roots. And to illustrate that, let's start with 16. So let's say we want to square root 16 and then square root that again. Well, one way of doing that is to first turn the square roots into fractional exponents. So remember that square root of something can be written as the something to the power half. So we can write square root of 16 as 16 to the power of half. Then the second square root, we can also write that as power half. So in this case, what we're doing is we've got 2 exponents on 16, each of them a half. And since we're doing exponents of exponents, remember we need to multiply them together to get the result. And a half times a half becomes a quarter. So all this is the same as 16 to the power of a quarter. Now, this 16, we know that it's 2 to the power of 4. So we can write actually the 16 to the power of a quarter as 2 to the power of 4, which is then elevated to the power of a quarter. And again, using the rule of exponents, we can multiply those two exponents together to get 4 times a quarter, and that's just 1, right? So we're left with 2 to the power of 1, which is just 2. And let's double check that. So if we first square root of 16, we're looking for a number such that when we square it, you will get 16, right? So square root of 16 is 4. And then if we square that again, if we square root that again, so square root of 4 becomes 2. and therefore we get the same answer. So this is another example of how we can use fractional exponents to manipulate square roots, especially when you've got more than one of them. So how do we deal with square roots or roots of large numbers? Well, let's see. So let's take an example, and in this case we want to calculate the square root of 72. So the first thing that we want to do is to break down the 72 into factors, right? So a factor is essentially a multiplication. So 72 we can write as 8 times 9, and 9 can be written as 3 times 3, and 2 times 2 times 2 gives us the 8. So we can actually write that number 72 as 3 squared, because we have 2 3's, times 2 squared times 2. So notice that we have 3 2's, so we can only pair up 2 of them, and we've got one odd one out. Now, why are we pairing these factors up in pairs? Well, it's because we want to use the rule of multiplications of roots. So remember that when you have a root that's over a certain amount of multiplications, you can split them, right? So we can write this square root of 72 as square root of 2 squared times square root of 3 squared times square root of 2. And quite a few of those are going to simplify, because square root of 2 squared becomes just 2. Square root of 3 squared becomes just 3. So that's why we pair these factors up, because when there's a pair, we can get rid of them, as in we can move them outside of the root and put them in front. Okay, so it's a little bit like in Snap when you're looking for 2 pairs, if you're familiar with the game. Once you've got a pair, you can move it outside of the root. So in this case, we pair up 2 2's and we pair up 2 3's, we move them outside the root. We're still left with 1 2 on its own, so we have to keep that in the final result. However, the 2 and the 3, we can then multiply them together outside the root. So let's do another example. So this time we've got a cubic root, and the number below is 54. Let's start by breaking down 54. So 54 can be written as 9 times 6. That 9 gives us 3 times 3, and the 6 gives us 2 times 3. What we can then do is we can regroup the 3's together, and we've got 3 of them, but we've only got 1 2. So here, we're not going to look to pair up because it's a cubic root. And to simplify that, we need a cube. So in this case, we're looking for trios of numbers. And it just happens that we've got 3 3's, so that's convenient. So what we can do is we can break that 54 into 3 cubed times 2, and then split the cubic root so that we have cubic root of 3 cubed, it's hard to say, times cubic root of 2. And that cubic root of 3 cubed is going to simplify. We're just going to be left with 3. And that's now before the root. Unfortunately, our cubic root of 2 stays there because that one we can't find any buddies to form a trio, and we can't move it outside the root. So the general principle is you first look to break down the number within the square root into different factors. And depending on what kind of root, you're going to group those factors as much as you can. So for square roots, you look to pair them up. Now, it's not always possible to get rid of all the square roots. So in this case, we've got a cubic root left of 2. But you'll find in the GMAT that doing this often simplifies the calculations enough to get to where you want to be. Let's talk about roots and signs. So you may already know that we can't take a square root of a negative number in math, or at least in conventional math. But we can take the cubic root of a negative number, and let's see why. So let's consider minus 27, and let's take the cubic root of minus 27. So the cubic root is a number such that when you cube it, you get the original number. So is there a number such that when you cube it, you get minus 27? Well, minus 3 actually works. And why is that the case? Because, well, you can think about it without the signs first of all. 3 to the power of 3 is 3 times 3, 9, times 3 again gives you 27. So cubic root of 27 would just be 3. But if you have a negative sign, what's going to happen is minus 3 times minus 3 is going to become plus 9. And times that by minus 3 again, it becomes negative again, minus 27. And when you've got an odd number of negatives, you end up with a negative number when you multiply them. So that's why actually you can take a root of a negative number as long as the order of that root is odd. So in this case, it's 3 because it's the cubic root. It would be the same if it were 5, 7, etc. Whereas for even roots, so for example, a square root, so here you could imagine having a 2 above the little symbol. Well, we could do 2 times 2 to get 4, but there's no way of doing something times something to get minus 4. Why? Because minus 2 times minus 2 becomes plus 4. So the two negative signs cancel out to get a positive. Now, one question that you may or may not be asking yourself is, well, when I have a positive number in a square root, for example, so 9, square root of 9, I could get that by doing plus 3 times plus 3 equals 9, but I could also do minus 3 times minus 3 equals plus 9. So which one is it? Well, by convention, square root of 9 is 3, and it's not minus 3. Right, so now let's jump back to that question we saw at the beginning that we said we would do in a minute. So let's go for it, right? So obviously here it's going to take a little bit more time than that because I'm going to walk you through it and how this works. But if you practice this a little bit and you do a very similar question and you can generate those in the app, well, you'll find that it's very easy to do in a minute, actually. So let's go for it. Right. So the first thing we want to do, or at least I'm going to do, is I'm going to make my head smaller so I can show you the rest. And we're going to start with the first part of the expression, which is the square root of 12 times square root of 3 over square root of 4. So remember that when you're multiplying and dividing roots, you can just combine them into one root. If you haven't already looked at that part of the video, I'd encourage you to do so now. If you're using the app, you can just click on the method cards and look at the video extract like this. So here, we're multiplying and dividing these roots together, so we can combine them together. And this essentially gives us 36 over 4, which we can write as 9 times 4 over 4. And that times 4, we can just cross it out because we're multiplying by 4 and dividing by 4. That brings us back to where we were initially. And so actually, this actually just simplifies to square root of 9, which is just 3. We could have actually, rather than combining the 12 and the 3 together to make 36, we could have just said, well, 12 is 3 times 4, and I can cancel out the 4 with the 4 at the bottom, and we're left with square root of 3 times 3 at the top, which is just our 3. Right? That's another way of doing it, which is arguably even quicker. Okay, so let's look at the next one, right? Which was I can't even say that, right? So it's not a square root, it's not a cubic root, but it's a root to the power 4, right? Or root to the exponent 1/4. Remember that a root can be written as a fraction, right? Again, there's a specific lesson on that you can jump to if needed. And why do we write it like that here? Well, because it's handy, because we know that 16 is 2 to the power 4, right? And well, you may or may not know that, but it is one of those sort of like recurring things in the exam, so it's worth learning that one by heart. And if 16 is 2 to the power 4, then this whole thing is 2 to the power 4, which is to the exponent 1/4. And remember, exponents of exponents, we can multiply them together. And that 4 times 1/4 will just cancel out to be left with 1. So we're left with 2 to the power 1, which is just 2, simply. And then last but not least, minus 8 to the power of 1/3. Well, power of 1/3 is like a cubic root. And so here, 8 is again 2 to the power 3, so that's going to cancel out, right? And remember that we have to be very careful with signs involved in roots and with exponents. So here, we've got a negative sign, and our exponent or root is odd. So in that case, that sign is just going to pop out of the exponent, and we're going to be left with minus 2. But when we combine these together, that minus 2 was after a minus sign, right? Remember at the start we had a minus and then this bit here. So that minus minus will actually cancel out to become a plus 2. So we're just left with 3 plus 2 plus 2, which just gives us 7, and that's the answer. So again, you can see that here, with a bit of practice, you can actually do this very quickly. And we're not actually using any complicated algebra or arithmetic here at all. We're really breaking down this complex calculation into very simple steps. And like the kind of steps that we're doing in terms of mental math is just like 2 times 2 times 2, or 9 times 4 divided by 4, which you can just cancel out to just 9, right? So we're keeping things very simple, and that is the GMAT way of doing things.